All right, so we're going to talk today about something called titration. And this is a technique that's used a lot in chemistry. We use it a ton in AP chemistry. And what it does, in this case, we have a chemical equation for neutralization reaction. So what we're doing is we have one thing, and we're reacting it with another. And the reason we do this in titration, it's to figure out, we might know how much, we might know this concentration, and this might be an unknown concentration. And through titration, we can figure out our unknown concentration. But we have to start with a chemical equation. So titration starts with a chemical equation, which we'll get to on the next slide. Okay, so now discussion notes for here. So take a minute and pause and draw this in to the best of your ability. This is called burette. And this is a flask. And this can be this is your known solution. And this is your unknown solution. And an indicator to tell you when your reaction is reached. Now, we use I'm just going to talk for a second. You don't need to write this down. We use the cabbage juice and the universal indicator last week, or however long ago it was from when you're watching this lecture. What an indicator is a substance that when it reacts with an acid or a base, it changes color. Now, really what happens is acids or bases change the shape of different molecules. And this tends to be what an indicator does. It tends to change the shape of a different of a molecule, or slightly alter the form of that molecule, and it produces a new substance that has a different color. So based on the concentration of H+, it will be one color versus another. So we can use, and we have indicators to measure all sorts of different pHs. You saw the universal indicator that could measure over a wide range. I think they have a number of different molecules in there that do that. The cabbage juice can also do it over a broad range, but that's not as exact as what we would want. So you wouldn't use cabbage juice normally for a titration. You would pick an indicator where it was a very clear change from one pH to the next based on the conformation of that molecule. Okay. So what is a titration? A titration is a procedure in which a generally neutralization, but I'm just going to say reaction. It tends to be neutralization, but you can also do different kinds, is monitored with an indicator allowing you to calculate the unknown concentration of an acid or base. So that's what it does. Now, we have this point called the equivalence point. When the equivalence, that's a C, point is reached, in a titration, the moles of, let's just say for neutralization reaction, the moles of H plus equal the moles of OH minus. So now you know if you have moles of H plus and moles of OH minus, you can calculate your concentration. So on the next page, I'm going to walk through one of these. The math may be a little bit scary. I'm going to break it down for you. It'll be okay. So let's go back to our trusty old HCl plus NaOH yields H2O and NaCl. So let's say I have my setup over here. You don't need to draw this in because you already did. And this is like my burette. And in here I have, let's do the ring stand. Okay, in here I have 0.1 molar, big M, molar, HCl. And down here I have NaOH. And I don't know what the concentration is. But I do know I have 100 milliliters. So what I want to find is, so I have my 0.1 molar HCl. Now let's just do it this way. HCl equals 0.1 molar. NaOH equals, but my volume of NaOH equals 100 milliliters. And we're just going to convert that to 0.1 liters right now. So I run my titration. And when my concentration equals, or sorry, when my volume of HCl that I've added equals, let's just make it easy, 50 milliliters, well then, all of a sudden my indicator flips. And I'm left with a colored solution. So I know that when my HCl volume equals 50 milliliters, my titration is done. So now I can go back here and say my volume of HCl equals 50 milliliters, which is 0.05 liters. Now, some of you right now might be able to immediately calculate the concentration of NaOH using the logic that, well, I only need half as much HCl as NaOH, so my HCl must be twice as concentrated. But I'm going to walk you through the math. So we know at our equivalence point, moles of HCl equal moles of NaOH. So I'm going to do this now in red. Going back to a couple weeks ago, finding moles. So my moles of HCl, well, I have 0.05 liters of HCl. And I know in every 1 liter, I have 0.1 moles. That's from this concentration over here. So I get 0.005 moles of HCl. Well, I know at my equivalence point, my moles of HCl equal my moles of NaOH. So I know I have 0.005 moles of NaOH. I want my molarity, which is this moles per liter. I divide this by 0.1 liters. And that's concentration of NaOH. Doing the math, I get 0.05 molar is the concentration of NaOH. So I know this is tricky. We'll practice it in class. There's also this handy-dandy equation, but I hate you guys memorizing equations. I'd much rather have you guys understand. But here's the overall equation, which is your molarity of one substance times the volume equals your molarity of the other substance times the volume of that substance. All right, wrapping up. How can a neutralization reaction help you figure out acid or base concentration? So titration allows you to calculate the unknown concentration of an acid or base or something else, but in this case, acid or base using a neutralization reaction. And during a titration, an indicator is used to signal when the equivalence point has been reached.